Signals from the Global Navigation Satellite System are one of the main inputs used for aircraft positioning or time reference for communication, navigation and surveillance functions on board most of the modern aircraft. Airline operators report an increasing number of events related to the loss of GNSS signals due to radio frequency interference during operations in some areas of the world. The Global Navigation Satellite System began in 1978 when the first satellite of the GPS constellation was launched. The full operational capability of GPS was declared in 1995. In 2000, the full availability was granted to provide improved performance of the GPS position for civilians. The number of users and uses consequently increased, especially in civil aviation. Let's take a look at what can cause radio frequency interference. A low-power signal sent from space. The GPS signal is a low-power signal. It is comparable to the power emitted by a 60-watt light bulb located more than 20,000 kilometers away from the surface of the Earth. This means that the signal could easily be disturbed by any ground source located near an aircraft and emitting in the GPS L1 frequency band, leading to the loss of GPS data. Some of the reported disturbances were caused by portable personal privacy devices that jam a GPS signal in the immediate area to avoid tracking. Operational disruptions at airports due to a loss of the GPS signal in the area around the airports have been caused when these devices were activated in the vicinity of an airport. Certain sensitive sites may be protected using GNSS RFI for security reasons, such as correctional facilities or sites where dignitaries or political figures are living or visiting. Aircraft operating in the vicinity of these sites may be affected by interference with the GPS signal. GPS repeaters are used to make a GPS signal available inside a hangar during aircraft maintenance. GPS repeater signals have caused interference with actual GPS signal in some reported events, causing reception issues on aircraft located close to the hangar. A TV broadcast station malfunction reportedly disturbed the GPS signal and affected aircraft operations. GPS RFI can also cause loss of the GPS signal in flight if too close to areas of military conflict. These areas are often known, and NOTAMs inform flight crews that they may encounter interference close to these areas. It can be the case that military RFI activity is not known in advance or communicated, leading to loss of GPS signal without prior notice. Some of the known radio frequency interference sources are reportedly capable of emitting signals that mimic GNSS signals. Objectives for such spoofing include providing GNSS positioning service within hangar with repeaters, preventing GNSS receivers to compute position over prohibited area, or triggering geofencing responses as part of anti-drone measures. There are no reported events of GNSS spoofing leading to wrong aircraft position and timing on any modern aircraft to date. During flight preparation, check RFI NOTAMs. Operators should consider the NOTAM related to known or expected areas with GNSS RFI when planning flights. If a NOTAM is applicable to the flight, then the availability of non-GNSS-based routes, procedures and approaches, such as ILS, VOR and DME, must be checked for the affected area. During flight application of ECAM-FCOM procedures, flight crews must follow the associated ECAM or FCOM procedures if a loss of GNSS signal occurs during flight with a cockpit effect. Loss of GPS information is usually temporary, and the normal navigation mode based on GPS data, GPS primary or nav primary, as well as the communication and surveillance functions, are recovered as soon as the aircraft leaves the area affected by RFI. It is therefore not necessary to deselect GPS in the case of RFI, as this would prevent the aircraft from recovering its full capabilities when the GPS signal is restored. Zones with ADS-B out required. If the GNSS loss occurs in an area where ADS-B out is required per regulation, the flight crew should notify ATC of the loss of ADS-B out and report that this is due the loss of the GNSS signal. At the end of a flight where the effects of a loss of GNSS signal were experienced, the flight crew should report the event and cockpit effects to the maintenance to investigate and confirm if the event was due to RFI or a result of a system or equipment malfunction. Operators should report any identified suspected GNSS RFI events to regional and international organizations, such as Eurocontrol's voluntary ATM incident reporting. This will facilitate and accelerate GNSS RFI event confirmation or resolution and enable the publication of a NOTAM to share information to all other operators flying near the affected area. At the end of a flight impacted by a transient loss of GNSS, a confirmation should be done to make sure that the effects encountered were due to RFI and not to a system or equipment malfunction. At the end of a flight affected by transient GNSS loss within an area with known RFI, Airbus recommends that maintenance personnel reset the system and test both multimode receivers, MMR. To ensure that there was no system failures, Airbus also recommends a system test of any equipment affected by a loss of GNSS signal based on the cockpit effects observed during the flight. Should any system test fail, maintenance personnel must perform troubleshooting in accordance with the associated troubleshooting manual task. If the GNSS is still impacted by RFI on ground, the aircraft should be moved out of the RFI area. A dispatch under MEL conditions should be considered if this is not possible to do so. At the end of a flight affected with transient GNSS loss within an area without known RFI issues, Airbus recommends that maintenance personnel confirm the root cause of the GNSS loss by studying all potential sources: aircraft system failure, GNSS constellation anomaly, environment masking, multipath or space weather events such as ionospheric scintillation. When all these potential causes are eliminated, RFI can be suspected. In this case, aircraft data should be sent to Airbus for further investigation. The number of reported transient GNSS loss due to radio frequency interference is increasing. The loss of GPS signal can cause a downgrade of the aircraft position computation capabilities. However, Airbus aircraft are designed to maintain position computation capability without a GPS signal by using IRS or ground nav aids data. Certain navigation and surveillance functions may be lost temporarily. When radio frequency interference is encountered during flight, the flight crew will be alerted to any loss of function or capability. The flight crew must then use the relevant ECAM-FCOM procedure associated to these cockpit effects. In most reported cases of radio frequency interference, there is a return to normal operations immediately after the aircraft has moved away from the affected area. During flight preparation, precautions should be taken when flying to or above known area of RFI to avoid operational burdens. When it is confirmed by the maintenance that RFI is suspected in an area not known to be impacted, the information should be shared with the aviation community